Hi, we're going to take a look right now at potential and kinetic energy. In particular, I want to talk about how to tell what mix of potential and kinetic energy we have at any one point. First, let's talk about these two things. Potential energy is stored energy like we have in a battery. Has some stored chemical potential energy. Kinetic energy is energy that's being used, and I can use this flashlight by turning it on. Now, I'm sure that you know that after we have a flashlight going for a while, eventually we're going to see the light from the flashlight dim, and we'll say something like, hey, this flashlight needs more batteries in it. And that is because the battery no longer has any stored energy that's usable for the flashlight. It's all been changed into the light and the flashlight and the heat the flashlight puts off. So you can kind of imagine this going down as we use the flashlight. So at any one point, the flashlight has a mix of light energy coming out, which is the kinetic energy, heat energy, also kinetic energy coming off of it, and the stored energy that's still in the batteries inside the flashlight. Regular things that don't have batteries, they're just regular objects, handle energy in a similar way. They can be a mix, and they are a mix of potential and kinetic energy. If I take a simple ball and I put it on the table, right now it has no energy. It's hanging out on the table. No energy in it, but I can add energy by taking some of my body's energy and using it to lift up the ball. Right now this ball has a ton of potential energy because I could drop it. And potential energy often has to do with location that everything is in. So once I drop it, what's going to happen? Well, what we're going to see is that the potential energy as it gets lower is going to become less because there's less distance between the ball and the ground. At the same time as the potential energy drops, we're going to see the kinetic energy go up because the ball's going to start falling faster. And that's what happens with a ball. That's a little hard to see though, so let's go ahead and switch over to some internet material that I found. So we're going to take a look at a skate park here and take a look at the kinetic and potential energy available in this skate park. I'm going to use the pie chart feature on this interactive. So let's get started. I do that by bringing this guy up here, and we can see the blue dot above his head. That is the pie chart. And as you can see, as he moves, if we follow it, you'll see the pie chart changing. Let me pause him here. Let's switch against the top. Okay, just like the ball we see when the skater is way up here, he has the most potential energy. Didn't stop him perfectly at the top. It would be all blue if I did, but up here, lots of potential energy. Because he's far away from the ground, the skater is way up here, away from the ground, and has the potential to, of course, make this journey back down the ramp. As the skater travels down the ramp, we notice that the potential energy begins to disappear and it's being replaced by kinetic energy because the skater is getting faster. We can see that if we keep going down, look what's happening. That potential energy is going to disappear. At the very bottom, suddenly the skater is only kinetic energy. This is the point the skater is probably going to be going the fastest if we were watching. It's also the point at which it can't fall anymore. The skater cannot fall any further. This makes the potential energy gone. What happens is the skater starts going back up the other side. Well, the kinetic energy disappears as the skater slows down. And the further the skater gets from the ground, the potential energy increases again. Until the skater gets to the top, at which time, once again, we're going to go back to having a solid blue circle here because all the skater has is potential energy. We can change the shape of the track. The same thing will happen once we hit play. It will just change a little bit differently as the skater goes up and down the bumps. The highest point will still be the point with the points with the most potential energy. and the lowest points will become the ones with the least potential energy. Let's go ahead and just watch that again, slow motion. Again, we see the highest point, which we have 2 of. The circle is going to be all the way blue. And as the skater turns around and goes the other way, just put that in slow motion, watch what happens to the circle. The only point in which we have only kinetic energy is the lowest point. There we go, right there. If we watch the skater at the one that's slightly higher up here, you'll see that there's still some potential energy because the skater is away from the ground. We will see the same thing with a roller coaster. As the roller coaster goes up the hill, you'll see the potential energy gaining, and then as soon as it starts to go down the hill, the potential energy switches to kinetic energy. So there's step 1. Roller coaster climbs up to the hill here. At the highest hill, it's completely potential energy. Once the roller coaster slides down the hill to point number 2, we can see roller coaster is still a little bit above the ground, so still has a tiny sliver of potential energy, but the rest of it's movement energy, kinetic energy. Step 3, the roller coaster is about to enter the loop. A little higher up, so we see the potential energy growing right here. And mostly, though, still at this point, kinetic energy. Upside down, there we go again. Again, more potential energy because it's higher off the ground, little bit of movement energy. Down to 5, lowest point here for this on this particular roller coaster must be here because this is all kinetic energy. So this is the point the roller coaster would also be going the fastest. We also see no potential energy, so that's how I know it's the lowest point. And then when we go here, we see once again the amounts have changed. A little bit of potential energy, mostly kinetic energy. Okay, so as you saw, the roller coaster was very similar to what we started with, talking about batteries and flashlights. As the kinetic energy is created, the amount of potential energy or stored energy goes down. And that, again, that's the same thing that we can expect with a flashlight. My stored energy on my battery runs out as I use my flashlight. Hopefully that will help you understand potential and kinetic energy a little better. Thanks for tuning in.